Hi, everyone. I'm Susan Nash, AAPG, and I just can't tell you how excited I am to have this really wonderful opportunity to welcome Dr. Saeed Salehi, who is director of the Geothermal Consortium at the University of Oklahoma, and his team members, Cesar Vivas and also Jeff McCaskill. And they will be giving us an update on how they are converting oil and gas wells to geothermal. That's an amazing and exciting topic these days, and it's very relevant for all of us, really. So I'm going to stop sharing my screen, and I'm going to invite Dr. Salehi to share his screen.
Okay. Can you see the slides?
Yes, welcome. It looks great.
Okay. Hi, good afternoon, everyone, and thank you, Susan, for inviting us. I really appreciate, to come to APG and talk to people about our project. So my name is Saeed Salehi. I'm the director of the Wealth Opportunity Geothermal Program at the University of Oklahoma. So last year, about the same time, we had the presentation about this project that was just picked up, and this year we are actually going to give some updates and some information about the progress that happened from last year. So you may see a lot of the slides being similar to what I presented last time, so please be patient. We're hopefully going to get to the information that are new, and then we're going to have a Q&A at the end. So so today at the beginning, I'm going to talk a little bit about the geothermal, about the field sites, some of the information, the data, and then I will give it to Cesar, which is going to talk about a little bit of, the techno-economics and, the cost numbers that we have done in terms of, using geothermal for direct use application in this project. And at the end, we give it to Jeff. Jeff is actually now reporting live from the field that we are doing this repurposing opportunity. So he's probably going to show you some exciting stuff. And at the end, we are happy to have some Q&A. So what I would like to start is a very interesting graphics from US Department of Energy, which tells you all about the geothermal. So a lot of people only think of geothermal as producing electricity, power generation, but it has a very diverse application, as you can see on the left diagrams. So we know about the heat pumps now. It's been decades that we have been using them. They are very efficient. However, the scale is small, so mostly using for residential facilities or a small application. And then, of course, we have hydrothermal going on for a long time in the geothermal industry, and they are now in terms of power production, but mostly in very active geothermal areas, volcanic areas. And then most recently, as you're following the news, with a lot of new startups are breaking grounds are the deep geothermal, such as enhanced geothermal system, super hot rock drilling, and the goal is use the learnings from oil and gas industry in terms of efficient fracking to be able to scale up, the power generation from deep grounds. And right now there are a lot of good news coming on with companies like Fervo making breakthroughs in terms of EGS. And in terms of the applications of the geothermal, as the title says, it's very diverse. We can think of pretty much anything, from fish farming to greenhousing to drying cement and aggregate to even, recently people are trying, using geothermal power for hydrogen production. So there is a range of basically different temperatures depending on the resources that are available to you, that you can, have the applications of geothermal for either direct use or for power production. And the other thing I want to mention is, as we already looked at the data, we know that basically U.S. electric generation projection to 2050, we're still relying too much on fossil fuel and fossil fuel resources. And to be able to switch to renewables, we have to scale up some of these technologies. As you can see on the right side, you could see that there's a very progressive growth has been on horizon for solar, wind, even hydroelectric. But based on the current projection, the share of geothermal is still small. So it's 2%, which is pretty much nothing. However, this may change based on the current breakthroughs that are happening. The new basically discoveries. In terms of geothermal energy, more than 64 million houses can be powered by geothermal easily, based on the projection that we hear from different reports. And one of the major opportunities that are currently going on is use the geothermal for more of the direct use, and even use of the current oil and gas resources for them, which is this project trying to have one of the early demonstration on this new area. So going to further on the discussion on direct use, there is a very interesting report from National Renewable Energy Laboratory that you can see on the chart, which is showing more than 65% of the electricity is actually going for space heating and cooling. So basically, we are using electricity to be able to heat and cool. And then you can imagine that if you are able to basically switch this type of end use by just directly using geothermal, you can prevent a lot of let's say carbon emission in converting or generating that electricity from gas power sources and use it. So the geothermal direct use is huge. The resources are very diverse. In fact, if you look at the map in the US, there are a lot of oil and gas reservoirs that have a good processing and permeability that can be leveraged for geothermal. Right now, it's mostly from hot dry rocks, but I think there are lots of opportunity in sedimentary basins all over the US in terms of knowing the potential. We have a lot of data, logs, and at the same time, we also have a lot of workforce that can drill, they can evaluate, they can explore, and the opportunities are very diverse and huge. So going to repurposing opportunities, there have been some earlier news about our project that we are thinking of using the fan wells and convert to geothermal. The use of fan wells technically is possible if they have they still have good well integrity conditions, we have enough data. But at the same time, it's very challenging knowing that a lot of these fan wells, they don't have enough data. So the major goal that we have been envisioning in our project is not really the fan wells, is basically the wells that are close to retirement, which we call inactive or idle wells, and try to evaluate those wells, in terms of the data, the well integrity, the information, the resource assessment, and try to basically use those wells or convert those wells to geothermal. And these wells are diversely populated in many states. You drive many backyards, and a lot of small towns, big towns around, and you can see these wells popping up. There are a lot of fields, there are lots of assets, pipelines, and there is opportunity that you can leverage some of these resources for geothermal production. So there are controversial data on number of, let's say, inactive, orphan, and abandoned wells, but estimate is huge. There are numbers here, some places more than 1 million wells. Even we heard that there are about 3 million wells that are becoming inactive, or including the orphaned and the idle wells. At the same time, according to the recent data, we have about 1 million active wells. So at some point, even these active wells needs to be sort of retired or P&A. So the opportunities that we can use this repurposing as a sustainable way of retiring oil and gas assets. So if you're able to learn even how to do this, we can drill new wells, or let's say we can modify the new wells based on using them for geothermal in the future when they are going to be retired. So a little bit information about our project. So this was funded by U.S. Department of Energy back more than now 1.5 years ago. So this is a field, or let's say 4 retired wells in Tuttle, Oklahoma, which are close proximity of 3 schools. So basically, they are very close to 2 of the schools that you can see here, Tuttle Middle School and Elementary School. And we studied these wells in terms of using them for geothermal application. And you can see on this schematic in terms of the distancing. So 2 of the wells, we have the forest distance in terms of well number 1 and number 3, and well 2 and 4 are, are in a shorter proximity. And the goal is that we are starting with using one of the wells at this moment as injector, and then produce from another as the producing geothermal well. And hopefully in the next phase, we are going to add the rest of 2 wells, either as injector or as producer, depending on the feasibility data and, collecting, the heat potential, or let's say, the production of geothermal energy from the current wells. So at this stage, we later, discuss about it, but the permitting was the longest process in this endeavor, because that was the first time that, somebody's doing, geothermal repurposing in the state of Oklahoma. So we navigated a lot of process. Even the permitting documents was sort of tricky. And then, but we are glad that we were able to clear the permit last month. And right now we are getting into the actual operation phase. So it's just some more information about the project. As you can see, the aerial view of the wells here. So a very positive thing about, the field and the location is that there is a big farmland between the location of the wells and the schools, and there is only one basically landowner that we have to negotiate. So that made the life easier in terms of working with just one person, and in terms of later on, if you continue this project in terms of the pipeline and the getting the heat from the wells to the schools, it would be easier to navigate the surface land. So the concept is fairly well construction 101 in terms of trying to have a semi-closed loop geothermal situation. So when I'm saying closed loop, I don't mean that they have been piped, but I mean that we are using the cruise media down there for recirculating the water and then producing from another well. So at the beginning, we were thinking of doing it above the oil reservoir. However, there was some challenges in terms of producing maybe some gas or even leakage to the oil reservoir. So that's why we sort of changed the plan, and we actually choose another formation that was in the couple of thousand feet above the oil reservoir for the actual geothermal operation. And that made some challenges because there wasn't enough petrophysical data in terms of the logs and permeability estimation. So we had to start from scratch and build models and basically collect the data, pores. And our team have been doing sort of feasibility studies in the past few months, building the geo models with the information that we collected, putting the wells information, and trying to basically simulate the potential for geothermal, potential for seismicity risk, potential for leakage, and the breakthroughs and everything. And luckily, or let's say based on the feasibility, the results are promising in terms of enough energy for not even the schools, but also for many houses around the school area. And we hope that be able to get enough information from the field application to further prove the hypothesis. So with this, I will pass it on to Dr. Cesar Vivas to talk about a little bit more on the data and everything here. Cesar, please.
Okay, thank you. And as we were trying to characterize and produce a geothermal project, we need to understand the resource. And the first thing that we have to do is to understand the geothermal grid in Oklahoma. Temperature is, and especially downhole temperature is data that we thought at the beginning that was easily to acquire, but definitely there is a lack of information. So we start to building like a big puzzle, but starting with the small pieces. And we collect data from oil and gas studies or information from the Oklahoma Geological Survey. So we initially start collecting that data, and then we start from these sporadic or points where we can collect temperature to something else. Actually, next slide, please. Okay, yes. So once we capture all the data that we have, we generate a geothermal gradient in Oklahoma. This heat map reflects the information that we have gathering during 2 years in order to understand how the geothermal resource, how is the geothermal resource in Oklahoma? Then we start building different layers of data. Please, next slide. In order to generate something that we call an interactive digital geothermal dashboard. So the idea is that we are going to put different layers. The first one is obviously related to the geothermal gradient and the geothermal resources. The second one is related to the oil and gas infrastructure. Is basically all the wells that are inactive and are available to projects of this kind. And a third layer consists of demographics. So demographics is basically data that is allowing us to identify potential end users. That can be industrial or residential end users. The idea to put all this information together is we can cross all these maps and generate something that allow us to identify potential zones that we are execute projects. Those projects, basically, you can identify what are the potential needs of the end users, and according to the information that we have from the reservoir, we can understand if we can provide geothermal energy efficiently for specific locations, such as the one that we are targeting now. Dr. Salehi, please, next slide. Like our total project in Oklahoma. So we extracted all the information, and with the help of the National Renewable Energy Lab team, we analyzed the information, and we found what is the heating and cooling demand for the facilities that we are targeting. Then, as we understand the downhole resources, we combine that information and then analyze what is going to be our potential or what is going to be our geothermal cycling targets. For one of the scenarios, we have identified that 2,000 barrels per day satisfy the needs of our potential our potential end users. So having all this information together, we use that for building the project. So Dr. Salehi, please, next slide. And that was the starting of our project. So our project was, we cut the ribbon on September 2022. And then we start working in the different stages that comprise this project. As Dr. Salehi mentioned, in January 2023, we started the permitting process, and that permitting process lasted around 10 months. And basically, that was the very first time that all parties were doing something like that, because there is no regulatory framework available for geothermal resources. So in that case, both parties were learning during the process. Now I'm sure that for future projects, this process is going to be more expedite. But at the same time, we were working in the underground model, in the subsurface model, and in the operational designs that is going to help us to build a project, and at the same time met all the requirements for the permitting document. With that, once we have these permitting documents approved in October, in November, we start operations drilling the monitoring well. In December, nowadays, we are executing the workover operations for our injector and producing well. And in January, we expect to start the production test and kick off our geothermal cycling. This initial part of the geothermal cycling is going to last 1 year. So we expect that in January 2025, we are going to gather information from 1 year. And in that 1 year, we're going to analyze the information. We are going to do this thermal cycling during different seasons. So we're going to have this information from winter, spring, summer, and fall, and see how the seasonality could affect or not our geothermal cycling, analyze the efficiency of the system, and obtain valuable data that can be used to benefiting the geothermal community in order to understand what we can obtain in projects like that, like this, and also try to replicate this. Okay, a similar project in other regions, not only in Oklahoma, but in states that have similar conditions that we have in Oklahoma. Oh, next slide, please. And for that, okay, initially we generated an engineering design. That engineering design covers multiple aspects. In the operational side, we work with the Blue Cedar Energy team. Blue Cedar is the company that owns the wells and allow us to do this geothermal cycling. And we are working together in order to build all the operations and following the best practices. We working in a company that has experience working in the area, allow us to also access contractors that have the same experience and benefiting of the oil and gas contractors available in Oklahoma. That is something that Jeff is going to talk a little bit later during this presentation. We made a lot of modeling in order to understand the resources that we have and also plan the operations. We have a key collaborator, the National Renewable Energy Lab team. In collaboration with them, we generate multiple scenarios, understanding not only the subsurface, the geochemistry of the water, and also subsurface aspects like the potential heat demand scenarios and pre-designs of the geothermal heat pumps. So all this engineering process is a process that is still going. I mean, as we acquire one piece of information, we are still applying that into a model. So the idea is that we are still working in this model. And in the end of the project, we wanted to deliver documents and provide data in order to benefiting the entire community to see, okay, how a project like this work, how we can how the thermal cycling happen and how the petrophysical properties and or the geochemistry of the water affects the results or the efficiency of the geothermal project. So now I pass next slide to Jeff McCaskill.
Yeah.
Thanks, Cesar. I appreciate it. It's a little hectic in the room right now, but so the permitting process started quite some time ago. We've been working for over a year now trying to get the permitting completed, and we're in the final days of that now. We have two separate state entities that will be in control of these wells. One of them for the producer and one for the injector. DEQ and OCC are the two entities. It's been quite the process. What it looks to me like is since this is something that's never been done before, everyone wants to be sure that they get it right the first time. And we are kind of laying the groundwork for future projects. Once that the permitting is in place, then we feel like that the next project will go much smoother. So it's been a lot of give and take, a lot of research has been done, and we finally got documents that everybody agrees with, and so we're pretty happy with that, and so we're moving forward. I'm actually on the well site for the producer today. As I said before, I am in the wireline shack right now. We're currently, I'll turn around and hope you guys can see the video.
We don't see anything there yet. Okay.
So I'm going to turn around here and show you this screen. Hopefully it'll focus in on it.
It's pretty tiny.
Yeah,
As long as we're sharing the screen, it'll be tiny, and it's not really focused.
yeah, it's very.
But we can get a good sense of what it looks like. This is cool.
Won't focus on it, but what we're seeing right now is our wireline tool is at 3,100 feet, and the weight on the tool is 856 pounds. We're coming back out of the hole right now so that we can do the next stage in working on the well. We've been setting plugs this morning. Here in the next probably 45 minutes, we'll be doing some perforating so that we can do some cementing. And so, yeah, that's the process. It's going to be about a 4 or 5 day process to get the well into condition that we can start using it as a producer. And we're currently on day 2. So I think we'll finish probably Tuesday of next week. So that's pretty much
Yes,
it.
Can you talk about a little bit on the monitoring well and why it was needed, the information about the monitoring?
Sure. So the screen that you see up now is some photos that were taken when we were installing the monitor well. This is required by the Department of Environmental Quality. We're required to drill the monitoring well down to the lowest formation of potable water, which in this area is around 400 feet. It varies a little bit. So DEQ told us that 350 feet would be satisfactory. So we drilled this monitor well to 350 feet. It's a 2-inch diameter. And then we took initial samples of that water and currently have those samples in a lab being tested for, we want to look at conductivity. We want to look to see if there's any chlorides. We need to know what the pH is. So we're going to do a whole battery of tests and we'll establish that as our baseline. The idea is that if we are down around the 6,500 foot area and we have any problems with well integrity in that we're leaking fluid, then we expect to see the leak show up in this monitor well. And we're required to take tests or samples from this water well on a monthly basis, and they have to go to an approved lab. And that's basically just to make sure we're not doing any kind of water contamination at all with our project. And so that well took a few days. They had some problems drilling it. Some of the casing that they tried to use was old and it didn't stay together. It actually parted in the well about 100 feet down. And so we had to go in and drill that old casing or the old tubing out and put some new in. So it delayed us about a week, but we have it installed now. As I said before, we've caught the samples from it so that we can establish the baseline, and we're just waiting on that lab to give us the test results back. So, however, initial testing looked like the TDS, total dissolved solids, and the chlorides, which are two things that we're most interested in, were both well below the limits that were necessary. As you can see in this slide right here, this is a photo actually from this morning. The two red tanks there are frac tanks. One of them has fresh water in it so that we can mix the cement that we need to put in the hole for our plugs. The other one is a blowdown tank. Interestingly enough, when we started on this well yesterday, Wednesday morning, we had 1,400 pounds of pressure on both the casing and the tubing. So we had to vent that, and so we blew that down into one of those tanks there. The larger white vehicle that you see on the left is the wireline truck, and that's actually, I'm inside the control room on that truck right now. And so you can see that there's pipes standing in the derrick. That's the pipe that we'll put back in when we get through doing the perforations and all the work that we're going to do on the well. And that's just kind of gives you an overview of the location that we're on right now and kind of how we have everything set up. Cesar, I don't know if there's slides for that or not, but okay. So unfortunately, my laptop won't focus on the well itself. I'd hope to be able to show you guys a closer view of things, but I've got some still photos that I could share with you at a later date. And it's very interesting what's going on here. So we're about to do a test on the last plug that we set. So things are going to get busy here in a few minutes, but that's kind of a little history of what's been going on, at least on my side so far.
Thank you, Jeff. Cesar, you want to get into?
Oh, yes. Yeah, definitely what we are obtaining about this project is basically wanted to show that Oklahoma has and geothermal energy has the potential to be a significant source of renewable energy in Oklahoma. And despite that, Oklahoma doesn't have the largest, the geothermal enthalpy or the enthalpy in Oklahoma is relatively low. We can benefiting of using the existing infrastructure and the existing amount of data sets from oil and gas industry and the multiple studies to help us to characterize and build reservoir models. So it's like we are not starting from scratch, but there is some data and resources and infrastructure that we can use for leveraging and making an economical and feasible geothermal production in Oklahoma. Also, another important part in Oklahoma that we have found is that there is a large amount of oil and gas workers, and as you see in the previous slides and the current operations, we are using a local oil and gas contractors in order to generating a geothermal project. So basically, having all this combination of resources in Oklahoma is allowing us to generate a project like this, and hopefully in an economical fashion. And again, the idea is that these kind of projects teaching us which factors are enabling or allowing us to develop geothermal energy in low enthalpy regions like Oklahoma and benefiting of all the resources that we have available in states like Oklahoma.
Wait,
So,
let me just.
Oh, yes.
Sure. We really like to acknowledge, especially the Blue Cedar Energy, not only the wells that they are donated, but also all the help that we got from them in the contracts and permitting process and everything. So without their help, we weren't able to be here. What we are doing, we're thankful to U.S. Department of Energy for providing the support for this project. I also like to mention our collaborator at Andrea that they are doing with a lot of feasibility studies. Also, I forgot the logo, but I need to acknowledge the Baker Hughes also helping us with some of the cost share that we use in this project and donating us the software. And thanks everybody for listening us today in this presentation. There is a disclaimer that we have to show regarding the presentation, so I'm including that. And we are happy to take any questions from the audience. Thank you.
Thank you. That was great. So we do have questions. I think some of them were pretty much answered during the presentation, but just in case anybody missed it, let's start with the first one. How deep are these wells?
Jeff, you want to get this?
Okay, the wells actually are in the region of 10,000 feet, but the geothermal zones are at 6,500 feet.
Excellent. What is the bottom hole temperature of Oklahoma wells? That's a general question. Might be better to ask what the bottom hole temperature of this one is.
Take that, or you want? Okay, the temperatures that we are expecting is in the region of 130, between 130 and 150 Fahrenheit degrees.
And that's Fahrenheit or Celsius?
Oh, in Celsius is 60 to 65 Celsius.
Okay, thank you. So Cesar, what tool have you used for the reservoir modeling?
Oh, okay, for the reservoir modeling, we initially use Petra and TechLog to analyze the well logs. We build the reservoir model in Petrel, and our initial geothermal modeling, we do that in CMG using the STARS module.
Okay, thank you. That's helpful. This might be for Jeff. What diameter do the injection and production wells need to be?
So the tubing in these wells is 2 3/8, and the well bore, I believe, is a 5.5 inch. Of course, the larger the well bore, the better. This is just what we had to work with, and so we still think we're going to be effective at this, even at this diameter.
Excellent. Okay, so will you be using existing tank batteries for the water flow?
So we're actually going to put the tank battery or the storage tank facility on the injector well site, and that well has no facilities there at all. It doesn't even have a Christmas tree on it right now. But Blue Cedar has some tanks that are sitting on the location where the producer is, and they also have some other tanks that they have graciously donated or said that we could use. And so it looks like we're probably going to set at least 2 300-barrel tanks on location for water in, water out, and then one of the tanks will be an overflow in case something happens and we can't get things shut down fast enough. They'll be piped together so that there's no spills on the locations.
Thank you. So there are two questions that seem similar, so I'll kind of ask them together, and they have to do with the economics. Have you done modeling on fluid cycling rates to make cost-effective projects, minimum well temp versus rates?
Yes, we have done multiple. Okay, yes, we have done that. We did an stochastic approach, and we run around 21 different simulations with different scenarios according to the uncertainties that we have, and that is the base of the techno-economical model that NREL developed from us. Our idea is there is a paper that is going to be published. So some of the aspects that I'm just talking about, they are going to be published. So once this paper is finally accepted and public, and we can make it also public, and you can extract the information from that. Anyhow, also we can be contacted, and happy to also discuss and talk about those details.
That's great. So here's another one that seems to be similar. The question is it's direct heat only, but here we talk about 10,000 barrels per day providing sufficient energy enthalpy for district heating.
Okay, the answer is yes. Okay, actually, what initially we did was to calculate what is the potential. Okay, what is the enthalpy needs for the community? What is going to be the consumption? And departing from that, we move backwards, and then we calculate what is the potential. Okay, what is the amount of production that is needed to cover those enthalpy needs? So yes, we contemplate that, but still, this is a first of its kind project. So we are still collecting data and understanding what is going to be the efficiency of our model, and we are going to consider different factors that can affect the performance of our model. So this is an alive model. basically we are still constantly iterating in order to cover all those questions and have the data to answer those kind of questions.
Cesar, if you can put in the chat the papers that was presented in Geothermal Rising, which went over some of these details, would be great.
Okay, yes. Yeah. Let me do that. I will put that.
That's great. Okay, so here's some more questions. Are there any concerns about hydrocarbons, either as a separate phase or dissolved in formation water, being produced as the fluids are circulated?
I can answer this question. So that was initially the concern we had at the beginning, because the target temperature we had was actually to go to TBD, which was 11,000 feet in the oil zone, and we had about 194 F temperature available for us. But then we had the concern that two concerns we had initially. One was that what should we do if you're having hydrocarbons or gas, oil or gas is produced by geothermal production? And the second thing was that we got some comments from our operator that injecting to the oil zone may impact actually the oil and gas production from the nearby wells. If there's a leakage to the reservoirs and that's nearby areas. So that's why we decided that completely abandon the geothermal production in the oil zone, and then we moved up to the depths of 6,500 feet that Jeff was talking about, because that's a non-hydrocarbon producing zone. So at this moment, we are not expecting, unless there is a gas recovery from there, but we don't expect that hydrocarbon produced from that. So it actually created some challenge for us, because as a non-producing hydrocarbon, we didn't have any log, we didn't have any cores, we didn't have any process estimates, so we had to start from scratch. We collected some outcrops from other places to be able to study the thermal conductivity, the feasibility to use that. So the answer is that we don't expect to have hydrocarbon.
That's interesting. Well, thank you. Okay, so what does the model suggest for the longevity of direct use application, considering thermal degradation of the reservoir?
Cesar, you want to take this?
Yes. Susan, can you repeat that question, please?
Okay, it's in the Q&A, so it's the last. It's from Anine Pedersen.
Oh, yes.
What does the model suggest for the longevity of the direct use application, considering thermal degradation of the reservoir?
Oh, that is a very good question. In general, we don't have a single model. I mean, what we did is, as I mentioned at the beginning, we did an stochastic model, and basically that we reflects the multiple uncertainties that we have. So we establish a range of potential temperatures, considering the minimum to be is around 120 and the maximum 150 Fahrenheit degrees, considering that different potential water saturation, giving an uncertainty for the petrophysical values. So this is what we did, is basically model this and generate an stochastic model and create scenarios, and the one that we are moving in is in the P50. Now we are going to evaluate using the information that we are going to obtain from the well test that we are going to perform, and we are going to do something that is named is a history match. So the idea is that we are using the initial test in order to make a history match with the data that we have in the model, in order to refine the model and then improve that. As this is a first of its kind project, we are as well from the modeling side, we are as well still learning and trying to finding what is the best approach. But hopefully we can, once we have done all of this process, We are okay. Hopefully, we can also publish this and mention what was the first approach or the best approach to find the closest values or the values that reflects more accurately what happened in reality.
Super interesting. Thank you. So here are two questions that kind of focus on the fact that this is a kind of two-stage process. So first is what you have to do in your workover to prepare the well to be repurposed. And then the second is after you get that going, what kind of retrofitting do you need to do does the end user need to do to utilize the direct heat or cooling?
I can partly answer this question, and then maybe I'll give it to Jeff to continue. I think the caveat here is the well integrity, stats of the wells, and that was the discussion from the beginning with the DQ and the regulators that, okay, what's the condition of the cement and the pipes here? Because the logs were, sort of from 20 years ago. So, things have changed. So that's the first thing that now we are going to do with this workover operation, trying to see that, the well integrity is sort of in good condition to be able to do this geothermal situation, because unlike oil and gas, you're going to do this cycling effects of cold and heat for years, so it may impact the cementing and the placing and everything. So that's what we're trying to learn with with this operation to assess the condition of well integrity. The second thing is depending on the way that you're going to repurpose, with the situation that we have right now that we are trying to do at depths of 6,500. So we are trying to put the plugs under the zone of the geothermal zone. So basically, we don't want to have any fluids to leak behind the zone, and trying to put plugs and then recirculate the fluids, and then have perforation to be able to maximize the formation take, and be able to to maximize basically the heat that can be harvested from that. Now the question is, what would the end user do at that site? There is also a lot of other details and the cost, because everything has been set for basically the schools are currently getting electricity from gas powered, and it's not basic geothermal. So we have to do some retrofitting in the schools, pending on future funding to be able to make it compatible for the geothermal that we are producing from these wells. But maybe Jeff, you want to talk about a little bit on the worker operation, what needs to be further done in terms of these type of projects?
Sure. So we're actually doing that work on the wells as we speak. We just came out of the whole set of a cast iron bridge plug and dumped some cement on top of that. We're doing a pressure test right now to make sure that the plug's holding. So initially, we needed to go into the wells and see exactly what we had in the wells. Some of the paperwork on these wells is quite old. These wells were drilled back in the early 80s, and it's kind of hit and miss as to whether we've got good information about the wellbores. And so we wanted to go in and evaluate the wellbores. This particular well was still had tubing in it down to a little below 10,000 feet. And since our geothermal zone is around 6,500, well, the first thing that we did is we had to pull the tubing out. And so we put about 6,500 feet of tubing is standing in the derrick right now. The rest of it we laid down. And so the owner, Blue Cedar, can come and repurpose that tubing. We also scanned the tubing on the way out to look for anything, any problems with the tubing. And surprisingly, we only found one joint that was just a marginal joint. So out of, I believe it was 331 joints, one joint is all we could find that had even anything that looked unusual. So, so initially on all of the wells, we're going to have to set bridge plugs and isolate those wells from any hydrocarbon production, because we're not interested in hydrocarbons here. We're only interested in geothermal. So we've gone through and done that today. We're finishing that up now. And then the next thing will be to make sure that we have a good cement sheath between the casing and the well wall. And then after we've done that, we're going to do a cement job. So we're going to perf in and pump cement back into the sidewalls. Then we're going to do a clean out, drill out the retainers, and then we're going to do a bond log to make sure that we've got good cement there. We've talked about running a caliper in there to make sure that the casing is correct, but from what we've seen from the tubing, there's absolutely no corrosion or anything on the tubing. So we may still go ahead and run the 7-arm caliper. That's a decision that'll be made probably in the next day or so. So basically, it's just get these wells where they don't communicate with hydrocarbon. And now we're going to tomorrow or Monday, we're going to reperforate into our zone, do a little acid job so we make sure we've got good communication with the zone. And then we'll start swabbing so that we can catch some samples of the formation water, do some testing on that, see what kind of flow we've got coming out of the formation. That'll help us size ESP pump if we need one, and get a liquid level in the well. And then we're ready to start producing at that point. So those are several of the steps that we have to do and that we're actually doing now. So hopefully that answers the questions.
That's great. I can't believe we have so many questions. This is wonderful. And these are wonderful answers too. This is so informative. And I wanted to say, Jeff, it's incredible that this timing, and want to thank Saeed and Cesar for Saeed actually mentioned that you be in the field. And so we are so fortunate that you can be talking live from where the action is. Anyway,
I was pretty excited about it too, Susan, and I'm disappointed that this camera won't focus, away, because I really wanted to show you as the wire lines were going in. When we first started this, they had just hung a bridge plug and were just going in the hole with a bridge plug, and I was really hopeful that I could show you guys that, but that's my only disappointment. So
yeah, you might have to go in the settings and make sure it doesn't say blurred background.
Yeah, that's a possibility. Yeah.
Yeah. At any rate,
I was kind of honestly scrambling around last minute to get this thing set up because, I'm paying attention to whatever else is going on with the rig and workover and so forth. So
oh no, this is good.
Apologies for that. So
no, safety first. And speaking of that, we have a question. What safety features were in place for the operations? How do you expect to control high pressures and high heat zones?
So we don't have a high pressure, high temperature zones here, really. As mentioned, this is a direct use application. The operation is very simple, well construction 101 that oil and gas industry is doing. Even the pressure is not that high. But I think the safety features are as usual for every other oil and gas or worker operation. Is there anything specific, Jeff, that you're doing in terms of safety, or is it just the normal routine?
no, all of the safety is exactly the same as it would be on any other oil field site and any other operation that would mirror this. We have BOPs installed, and then the hard hats and steel toes and FR and all of that stuff, safety glasses, all of that's being observed. And so there's really nothing that's specific to geothermal that's going on. This is just kind of a hybrid oil and gas operation right now. So that will change once we get the perforations done. But yeah, it's just a standard oil field deal right now.
That's great. Okay, so we'll time for a few more. Let's say, did you run any multi-finger caliper or corrosion logs?
No, we have not run a caliper in yet. As I said earlier, there's some discussion about running a caliper after it's all over with. But to be honest with you, the casing looks like it's in, just by looking at the tubing that's come out, I see no corrosion on the tubing at all. And we're doing pressure tests right now on the plugs that we've set. And so those pressures are all coming back great. We're not losing any pressure at all. And so it looks like everything is in good shape. And I'm really thinking that all of the people that we've got working here that have done this for years are looking and saying, you know, there's really no need to run calipers because everything looks like it's in good shape. So
How,
Probably-
when
probably
was the well first drilled and completed?
from all I can see from documentation I've been able to find, it was in the early 80s that the well was drilled. They were in it. They were in it, did some workover work on the well, and probably about mid-90s, 95, 96. There was an attempt in the other well that's going to be the injector to go into another zone. So they perfed into the Tonkawa zone, and that came up dry. And so we've got those perfs that have been cemented over. It was required because there were some other wells in the area that were going to try to produce the Tonkawa as well. And so, yeah, that's
Now, is this a Peru or what is the Pennsylvania formation?
Cesar. I think you
Okay.
could probably.
Okay, we have the formation that we are targeting is the Haskell.
Oh, okay. The
And-
Haskell? Mhm.
Yes,
That's a Pennsylvanian sand.
this is, yes, I think that, I'm not geologist, but okay, that belongs to the Douglas. Actually, that belongs to the Douglas group. Douglas group is basically Haskell and Tonkawa, and this is part of the upper Pennsylvania.
Okay, that's very helpful. Okay, so is the casing full of native brine?
There was very little liquid in the casing when we started yesterday. Probably not more than 5 to 10 barrels. We have since loaded the hole today so that we could do pressure testing on the cast iron bridge plugs that we're installing. And so the hole is loaded now, and we will remain loaded on the hole until, well, probably all the way through. So, yeah, it wasn't, but it is now.
Nice.
Susan, there are some questions about the papers. If anybody wants a copy of papers, please feel free to contact either me or Cesar. I put my email so we can, share a copy of the papers, and we are also launching a website for this. So hopefully we're going to upload, all the papers and even, the data from the field, to this one. So thanks everybody for attending.
Yeah, this is exciting. So I guess we have time for one more question. If we missed any of them, blowout preventer doesn't sound like are the legislative rules in place that address the movement of high volumes of hot water?
Legislative, you mean sort of, I don't think there is an established document in terms of, really, how much volume can be moved, or this is just so unique and, to the area and the geology and the information. So pretty much based on the models that we have built and, the data that we are putting in. And I don't think there is anything, I mean, there are lots of papers published in literature, but I think this is sort of a unique, basically, operation, going back into the current wells and using the 5.5-inch diameter to do this. So this is just very unique to these wells. So hopefully after we get the data, we can, maybe write some rules, but so far, we don't have that data.
That sounds good. Well, I think we've pretty much hit all the questions. We've answered them, and I just want to thank everyone for attending, and then specifically thank you, Saeed Salehi and Cesar Vivas and Jeff McCaskill for this amazing presentation and document, and then conversation from the field, from the operations.
Thank you, Susan. It was a great talk. So thanks everybody for attending.
Yes, and just as we wrap up, I want to thank our sponsors. We have, and they are all involved in repurposing aspects of orphan wells. And so we'll have a conference in Pittsburgh on orphan wells, and one of the topics will be repurposing orphan wells. So with Heath Environmental, Zafiro Methane, Purvis Energy Advisors, CSR Services, Capstone Welling Integrity, and the Well Done Foundation. So thanks again. You'll be receiving an email from me with a link to the recording and also a link to our upcoming webinars. And thank you again.
Thanks.
Okay. Thank you. Thank you, everyone.